All right, now we're back to the second half of this here. So hopefully before the second half here, you should have watched the YouTube video I linked you to. And this is something that it was a commercial that I remember watching a while back for DirecTV here. Now, you know, the first thing you should have noticed here when you were listening to the commercial, aside from its sheer absurdity, which is, you know, part of why the commercial is so useful, but notice the statements that the narrator is making. A lot of the statements the narrator is making, there seem to be, first off, there's a lot of commonalities, right? There seems to be sort of the same things happening in back-to-back statements. Furthermore, it feels like there's some sort of linking going on, some sort of flow, that you go from the first statement, you go all the way to the last statement, there seems to be things in between that sort of connect them together here. Now, note that the narrator made a bunch of statements, and those statements happen to be, you know, they sounded like conditionals, but they didn't use the formal if-then structure that we are accustomed to in Boolean logic. So what we can do is we can actually create that. We can, you know, modify the statement so that we do create something like this here. So for instance, we can say something along the lines of this. So the first two sentences of the commercial will be something along the lines of, you know, when you wait forever for the cable guy, you get bored. So that we can convert to, if you wait forever for the cable company, then you'll get bored. And then the second one similarly can be converted to, if you get bored, then you start staring out windows. So what's going on here, again, we can convert this into symbols. So our first thing we can call A implies B here, right? If you wait forever for the cable company, then you get bored. And when you get bored, you start staring out windows here. So notice how what's going on here, this feels like a flow, right? These two together appear to be the fact that we seem to have A leading to B leading to C here, right? So it seems like there's sort of this thing going on here where we have this linking between A, B, and C. Now, of course, one seems to be, the thing about conditionals is that they only have two components. They have an antecedent and a consequent here. So this B here, so first off, we know that this B is common to both. So it seems like in this case we can sort of cut out the middleman here and just focus on this and go straight from A to C here. So it makes sense that our conclusion should be A implies C. Or in this case, if the commercial stopped there, the conclusion that seems to be valid is that if you wait forever for the cable company, then you start staring out windows. And notice that we can actually continue this as you go on. We just add more of these conditionals as you go, and eventually you get to the point where you're attending your own funeral with a different name, which is a little strange, but I suppose that works. So what we have here is this idea that there's a chain of conditionals that are being glued together here. So we refer to this here, what we know as, this is known as the chain rule. Okay? So, now the reason that we call it, you have a different name, the law of syllogism here, is because it turns out that the chain rule actually has a different meaning in a different branch of mathematics. If you know anyone who's taking calculus, chain rule actually means something completely different. So we use this to we use syllogism here to distinguish that from the chain rule in calculus. So basically it's telling us here that, you know, if two conditionals are true and the consequent of one is the same as the antecedent of the other, then the antecedent of the first conditional implies the consequent of the second. Essentially what it's telling us is this, that if P implies Q and Q implies R here, then P implies R. This is just a really, really long and wordy way of saying you chain these things together, you glue them together, and you have this sort of thing like this. So you can kind of write it out like so. You have P implies Q, Q implies R, then you have P implies R. Note that much like the other laws that we've looked at here, the law of detachment and the law of modus tollens here, we can also write it out as a statement like this. And we can take a look at this sort of thing here, where we have this sort of statement written out in this form. We can write it out like this. P implies Q and Q implies R. All of that together implies P implies R. So in this case here, what we can do is we can actually, you know, show that this is true by utilizing a truth table for this. And that's something that I'm going to leave as an exercise to you, or if you'd like, we can talk about it during our live session here. That's something you might want to consider. But note that now we have an additional thing to add to our pool of laws that we can look at here, and they all seem to work out really well. So we have this here, okay?